Now we're kind of rounding out our study of chapter 1. We have this section, which is just generally solving other types of functions. We have one more lesson after this, which is about inequalities. This is going to feel a little fast and furious because we're going to go over solving like 2 to 3 other types of equations in ways you may not have seen before or you saw once and forgot about. But hang on with me, we'll be okay. The first type of function we're going to be solving is a polynomial equation. Technically, a quadratic is a polynomial. So some of this is going to look familiar. We can solve polynomials with linear skills, with quadratic skills, or with higher order polynomial skills, which is what we're going to practice today. But basically, we're going to want to make sure that all of these problems we are starting by moving all terms to one side, thereby obtaining 0 on the other side. So we do want these to be set equal to 0 so that we can factor. And remember, factoring is getting it with a bunch of parentheses showing. When we factor, we always really want to start by checking for a GCF. That's going to be your key, so maybe write that down for yourself, that we're going to want to check for a GCF first because hopefully that will allow us to make the equation significantly lower degreed. In this problem, we need to set it equal to 0, so I move 27x squared to the left-hand side so that it's set equal to 0. And then I want to start factoring. So we check for a GCF. Is there a GCF? 3 and what? X squared. Yeah, we can take out, basically divide all of these terms by 3x squared and figure out what our leftovers are. 3x to the 4th divided by 3x squared, so taking that out is going to be x squared. Negative 27x squared divided by 3x squared is negative 9. Now we have to continue breaking down that binomial in the parentheses because it's still power 2. So we have to give it a shot to see if we can break it down. This is the difference of 2 squares. Yeah, so if I rewrote this, you don't have to write this part down, but just to see, isn't 9 3 squared? So I could rewrite this middle part factoring by the difference of 2 squares, which means it becomes x plus 3, x minus 3. I said it backwards, but I wrote it fine. So that was the difference of 2 squares there. It is fully factored because I have as many parentheses spread out as possible. It's in fully factored form. And to finish solving, we set each of the factors equal to 0 like we did for a quadratic. So we do 3x squared equal to 0, x minus 3 equal to 0, and x plus 3 equal to 0. Well, what number squared times 3 would be equal to 0? 0. The next one would solve to 3. The next one would solve to negative 3. So the 3 solutions I have here for this polynomial are 0, 3, and negative 3. Look familiar? Here's one that may not be as familiar to you. This is called factoring by grouping. This is the one you're going to use when there are 4 terms. How many terms? 4 terms. That's when you're going to use factoring by grouping. It's actually very simple for 4-termed polynomials, but it's not super popular because, again, the chances of you having exactly 4 terms, light. But what we're going to do is we're still going to set it equal to 0. So we would have x cubed plus x squared minus 4x minus 4 equal to 0. You are going to, in your brain, split this into 2's. So in your head / on your paper, you're going to split it in half. In front right there, what do those 2 terms have in common? The x cubed and the x squared. X squared. So I'm going to factor out the GCF of x squared for both of those terms, which means I'd be left with x and a positive 1. How about those second terms? Negative 4x and negative 4 have negative 4 in common. When I divide that away, what's left over? X and 1. Oh, snap. Look at what I drew in purple. What color is that? Blue. Look at what's in blue now. What do you notice? They're the same. They are now the GCF of this term and this term. So I can factor out this GCF of x plus 1, and I can put all of my leftovers back, which is x squared minus 4. That is factoring by grouping. I've split it in half. I found the GCF of the first two, the GCF of the second two, the GCF of the GCFs, which should be the same. If it's not the same, you've messed up somewhere. And then I was able to factor. Now we are asked to solve this one, so we're not done just factoring. In fact, we're not even just done factoring. Does anyone recognize what this is? Yeah, this is the difference of two squares again. So this actually factors out to x minus 2, x plus 2, because that's the difference of two squares again. Trying to skip a step where I'm like saving some work here. We would set each factor equal to 0 and solve, but these are all easy to solve. From that first parentheses, what should x be equal to? -1. From the second one, what should it be equal to? And then, great, you just literally take the opposite sign when they're single step equations. Factoring by grouping, again, used when there are 4 terms. That's our polynomials. That's kind of the extent of what we're going to see with factoring polynomials at this point. A lot of other tools can be used to factor higher degrees, but we're going to want to make sure we can factor out GCFs and difference of two squares, and then do grouping and potentially difference of two squares again. Anybody want to ask a question before we flip the page? Okay. On the back, we're going to solve some radical equations. These are really fun for me, so I love doing them, which means you have to at least pretend like you like them, because I think they're so much fun. I've already worked one and completely out for you, but what we're going to do is we're going to annotate with words what happened each step. So starting from the jump, it says solve, it has the equation. What did I do from here to here? What do you think I was trying to do there? Move it to the other side, because what am I trying to isolate here? We want to isolate the radical. So if we're solving a radical equation, we're going to start by trying to get this radical by itself, which is why, yes, I did move the -2 to the other side, or the 2 to the other side, it became negative. Cool, great. Maybe write that down for yourself. We isolated the square root. In fact, I'll write it down for me as well. What did I do from that first, or that second step to the third? I squared both sides, but it gets rid of the square root. Let's get this over. Okay. Next, what happened? I did a FOIL. I expanded that binomial. I FOILed it. What next? Yeah, I set the equation equal to what? 0. This step, it looks kind of funky because I moved things to the right. We're not used to moving things to the right side of an equation. We like them being moving to the left. You're always going to want to move it to where the x squared stays positive. So since the x squared was positive on the right side, I'm moving stuff to the right to stay positive for the x squared. What did I do after that? I factored, and then I solved each of those little factors for their numbers. Here's the problem, though. This is not the correct answer. Let me rephrase. One of these is not a correct answer, because with radical equations, radical functions, there are restrictions to your domain. Can you take the square root of a negative number in the real domain? No, not unless we go to imaginary numbers, which means we may have what's called an extraneous solution or extraneous roots when we solve these. So we always, always, always have to check our work to make sure that the number makes sense, which is the step we're going to do together.
Well, that was wrong either way, even if the negative wasn't the radical.
Oh,
And it's x equals 1.
word, yeah, that's supposed to be a 1. typo. Okay, but let's check our work just to see and make sure now that I fixed that typo that we don't have another extraneous solution. So we're going to go to the regular equation itself, and we're going to type those numbers in, or plug those numbers in. So 2 times 5 minus 1, we're going to check and see if that is equal, I guess it's plus 2. We're going to see if that is equal to 5. So I'm plugging the number I got in for the places where x is. You can do this with the calculator, or you can do this with your brain calculator. This would be 10 minus 1 plus 2 equal 5. 10 minus 1 is 9. Square root of 9 is 3. 3 plus 2 is 5. So that one's good. Check. We're all right with that one. Let's check the other one. This is 2 times positive 1, when you ignore my typo. 2 times 1 is 2. 2 minus 1 is 1. Square root of 1 is 1. But does 3 equal to 5? No. So that means we're going to have to get rid of this one that does have a typo in it. That is an extraneous solution, and our only actual solution here is x equal to 5. So checking your work in this is not just something your teachers are telling you to do so you get the problem right. Like, you actually have to check because there's a possibility one or both are extraneous solutions.
It would be 3 doesn't equal to 1, right?
Oh my gosh, yes. You kept saying that and I was like, I don't get it. And I just kept plowing through what you were saying. Yep. Thank you. Okay. Now you've seen an example. You kind of get the idea of the steps. We're going to work this next one together because it's algebra. The algebra involved with it is those steps we just wrote down, but gets a little crazy. Because what do you notice in this example that was not in the one above it?
There's 2.
Yikes, there's 2. We're going to follow the same steps. Our steps were to isolate one of the radicals. I'm going to probably want to isolate the one that's already positive, so I'm going to leave square root of 3x plus 1 by itself and add square root of x plus 4 to the other side. I've isolated. After we isolated, what was the step we wrote down? Square both sides. I know automatically that means that the square root goes away, and I'm going to square both sides. Now I'm going to show an extra step on the side here because I think for a lot of us actually seeing this written out instead of just with a square but actually writing out what we're going to multiply would be really helpful. This is an optional step if you need it. We said the next step is to FOIL. If we're following the FOIL for the blue stuff, what is 1 times 1? This FOIL. Boom. 1. Then we FOIL. What are the outsides? 1 times square root of x plus 4 is 1 square root of x plus 4. That's first, that's outer. We go inner. That's this right here. Square root of x plus 4 again. And then we multiply the lasts. What is square root of x plus 4 times square root of x plus 4? What happens when you multiply 2 of the same square roots together? They cancel. This just becomes x plus 4. Now if we clean this up a little bit, I see that there are 2 of the same square roots in the middle of this equation. So I'm going to add those together and I'm going to get 2 square root of x plus 4s. And I'm actually going to erase this and put 5. Where did the 5 come from? The 1 and the 4. The front one and the very, very last 4. Yeah, I had 2 constants there. So again, if we stop where we're at, we have isolated one of the square roots. We squared both sides. We FOIL. We start to combine like terms. After we FOILed in the one above this, what was the step that we did? Set it equal to 0. Now that makes sense if there were no more radicals. But what do you see is still in this equation? A radical. So instead, we're going to repeat the process, isolating that radical. So I'm going to move the x to the other side. I'm going to move the 5 to the other side. And I get 2 radical x plus 4. Is that radical all the way isolated yet? No. We still got a 2 in front of it. How do you get rid of a 2 in front of something? Move it how? Divide. Very good. So I'm going to divide both sides by 2. It does not go inside that radical. It just divides away the coefficient of the radical. All right. Process starts over. We've isolated the radical. Go back to the top of your list. We just isolated what's next. Square both sides. We FOIL. This one might be easier to do without having to expand it. This is x squared minus 4x plus 4 equal to x plus 4. Now that the radicals are done, now that we've FOILed, we set it equal to 0, yeah? Keep the x squareds positive, so I'm going to go towards the left side this time. So it's x squared minus 5x equal to 0. The 4's cancel each other out. And we check for a GCF or factor. Is there a GCF between x squared and negative 5x? Just an x. If we factor that out, I get x times x minus 5, which means my two potential solutions are 0 and 5. Now we check. Now, I'm going to pause for a second, though, because that's a whole lot, and I might have lost some people. So while you're checking in the open space you have on the side, if I lost somebody somewhere, flag me down, and I'll come point at your... Okay, I'm coming. If you plug these in, which one did you have to throw away? 0, yeah. We have to check our work because one of them is extraneous. So again, checking your work's not optional, quote unquote, in these kinds of problems. It's part of the process. These ones are kind of gnarly, so if you have an additional question to ask, now would be a great time. Because when we flip the page, we're solving a different kind of equation already. This other section is kind of wild. Yes, sir. This 4x right here? Great question. I'll show my work in a second. So where did the 4x come from is a great question. If I follow the steps that I did above, what I'm doing here is I'm doing x minus 2 times x minus 2. So if I FOIL that, it's x squared minus 2x plus 4. And that combines to minus 4x. Yes? Okay. Thanks for asking. Okay. The next kind of equation we're solving, and I know it's fast and furious, but 2 easies, 1 hard, is that's all we have left, is a rational exponent. The rule with rational exponents is that this time we are isolating the term with a power, and then we just have to raise the other side to the reciprocal power. If m is even, you'll include the plus or minus symbol when you're writing your final answer. I would probably highlight this bit because this is going to be the thing you forget, because that's the thing I always forgot when I was solving these kinds of equations. So if we look, I've got this one filled out for you. we first step are isolating the term with the power. So again, here's the term with the power. So we would add 6 to both sides. Still not isolated. We divide by 3 on both sides. It's finally isolated. We're good to go. To solve this, I simply raise the other side to the reciprocal power. This is x to the 3/4, so I raise 2 to the 4/3, the reciprocal power. That's technically canceling out those powers the same way squares and square roots cancel each other out. After this, it really depends on what kind of answer you're looking for.
Where did that 2 come from on this side?
6 divided by 3.
Oh, the 3 in the front of the x. She moved it over.
Yeah, because I got to get this by itself. Divide by 3, divide by 3.
I saw it go from like.
You're like, where'd that come from? So like literally all of these are appropriate answers, just depending on how you want the answer written. If it's okay leaving it with what's called a rational exponent, you leave it like this. I'm cool with that if it says rational exponent. If it says in radical form, that's what it would look like. Notice that the number from the denominator became the index of the radical. That's literally all that happened. This last one is called, or the third one is called simplest radical form. I missed a letter. Radical form. And the last one, a decimal approximation. So depending on how I'm asking you to give me the answer, could depend on how you could change how you write the answer.
Did you make these? Yeah.
Can we try one together?
Because it'll help you with homework. This is a sketch right there.
So to solve this one, we want to isolate the term with the power, which means my first step is to do what? Move over 3/4. So I'm going to end up with x to the 2/3 equal to, and I'm just going to show my work here, 1/2 plus 3/4. Well, obviously, we've gone over some fraction rules before. Can I add those fractions right now? No, they have to have a what? Common denominator. So I'm going to give them a common denominator. I had to multiply by 2, so I multiply by 2. What is negative 2/4 plus 3/4? Negative 2 and then positive 3. 1/4. Yeah. Okay, we have the term with the power isolated. We're going to raise both sides technically to the reciprocal power. And that reciprocal power we're raising it to is 2/3. Since the numerator is even, what numerator, Miss Quigley? Thank you for asking. This numerator is an even number. We have to include plus or minus in front of this problem. Yes? We sure do.
The 2/3 is to
Yep, it sure is.
move it to the other side. You have to flip it.
Yes. I highlighted the wrong fraction and wrote the wrong thing.
Oh, yeah. Like how
Thank you for catching my mistake. Yes. But again, since that 2, the top power there, m over n, is an even number, you will still add plus or minus. I highlighted the wrong number. I'm very sorry. Now, this is something we can actually find out because 1/4 raised to the 3/2 power, when you do this in your calculator, somebody do it in the calculator, 1/4 raised to the 3/2 power, it doesn't come out to an ugly decimal approximation. We don't have to worry about all those 4 different forms of the equation that it could be written as. It actually just can be written as plus or minus, what do we get? 1/8. So plus or minus 1/8 is the only thing you would need to answer for this question. Yes.
How do you turn a decimal to a fraction?
Math, so to type the decimal in or have it in there, you press math and the first option says frac and then enter one more time. You're welcome. Okay, this second to last, is that true, second to last? kind of equation we're solving, you've probably never seen before or we're never taught this, so I promise you I will slow down, and I know I keep saying that and going fast. But this type of equation is called quadratic in form. Okay, I would highlight that because it is not a quadratic. It is quadratic in form, meaning that if we do a little bit of substitution before we start this problem, we actually only have to factor a cute little trinomial. It is quadratic in form. On first instinct, most of you say, Miss Quigley, that is a cubic or a quartic function. I agree. But if we do a little bit of substitution, so I'm going to let the letter u be equal to x squared. Where did I get the x squared from? Thank you for asking. You could use any letter. It's just naturally in math, if you're doing a substitution like this, you would use the letter u. You could pick what you want. I'm going to use u. I got the x squared there from the variable next to the b term. If I let that happen, I can rewrite the question that was given like this. X squared squared minus 8x squared minus 9 equal to 0. I know, what is happening is a great way to ask what is happening, because you're right. What do you notice? Okay, literally all I've done, let me back up. All I've done so far is taken x to the 4th power and rewritten it as x squared squared. 2 times 2 is 4, yeah? Okay, that's all I've done.
So you would just put u squared minus 8u minus 9?
Because I'm substituting u for all of the x squareds. I'm just going to take those out for a second. I'm going to say, hold on, pretend like that's not there.
To make it simpler.
It now looks like a quadratic, yeah? Not yet. They're substituted out. Well, we're going to put them back later.
No, look, u equals x squared, so we're x squared.
Yeah, a u substitution, which is what this called, is basically you telling the equation, hold this for a second, I'm going to make it simpler, and then like later we're going to take it back. If it looks like this is a quadratic that we can very quickly factor. Or not x, sorry, this should be a u. This factors to u minus 9, u plus 1. But remember, we didn't start this equation in terms of u. So we got to put it back in terms of x. If we put it back, this becomes x squared minus 9 times x squared plus 1. Before I move on, do we understand the u substitution part? I took away the x squared for a hot second, made it look simpler for myself to factor it, and then put it back.
So you just took away to bring it back?
Say again?
You just took away to bring it back?
Yeah.
How do you know that's the one you take out?
For the substitution, it's generally this right here next to the b term.
The 8, that, you know what?
Pretty much whatever's there.
An equation, so u times u would be u squared. That's where that's squared. And then first, that's outside plus u, inside minus u. That would equal gonna give it. The plus u and the minus u is just factoring it back down. Oh, okay. That's what we did way over.
Correct.
Okay. Look, like this, like x squared minus 9 went down to x plus 3 and x minus 2.
Now, notice we're not technically done because we want to try to get these as small as possible. That first parentheses is going to factor by the difference of 2 squares really simply. Does the second factor by difference of 2 squares? So I factored this into these two, yeah? How about that second one? Can I do that to plus 1 and minus 1? Why not? It's a plus. This only works for it's a difference of 2 squares. So I actually cannot factor that anymore. That is the fully factored form of this equation. And I ran out of room, so I'm going to have to scoot over. If we're solving these, the first two, real easy. X is equal to 3, and x is equal to negative 3. But the last one I'm going to show my work on, because if I do x squared plus 1 equal to 0 and start solving for x, that's x squared equal to -1. That's x equal to plus or minus the square root of -1. And what is the square root of -1? No, it was I.
Oh, it was I.
Yeah.
Oh.
So we have our 4 solutions. I nodded, but you weren't looking at me, so then you panicked and took it back. I was over here nodding, but not saying anything. That is called an equation that is quadratic in form. It's not quadratic, but we can totally make it look like it and then solve it using our quadratic skills. Can we just see another example of this before we ask any questions? And I'm telling you that because it's already filled out. It's already filled out. So if you notice, we have a quadratic in form equation. Like Amelia asked a second ago, how do you pick what u is going to be? This is the same thing. I can rewrite this as 5u squared plus 11u plus 2. Factor using u's like a quadratic. That's what's happening here. Substitute the u back in and solve these separately, this time using the radical exponent rules down to our solutions.
So we did 1/3 because 2/3 can't go into 1.
Well, we did 1/3. That's a great question because if you do x to the 1/3 raised to the second power, don't these multiply? And
Yeah, so
1/3 times 2 is 2/3. Okay.
What if there's 2 powers and one doesn't go into the other?
It wouldn't be quadratic in form. We'd have to solve it using a different technique. Yeah. We're not going to worry about B. Okay. I will fill it out on my notes and have it on the online copy of my notes, but I want to get to something that you'll feel better ending with what we're about to end with. Absolute values. Okay. Absolute values have very, very easy rules. It's a thing you want to avoid in school, but the rules for solving an absolute value equation is ISS. It stands for isolate, separate, solve. Avoid it in school unless we're solving absolute values. Isolate, separate, solve. Literally, that's what we're going to do. We're isolating the absolute value bars. We're separating this into the absolute values being equal to the positive constant and the negative constant, and we're solving them separately. 2x minus 3, absolute value, equal to 11. Are the absolute value bars isolated?
No.
There's something else over there?
No, they're isolated.
They're isolated, yeah. So remember, the bars themselves, are they it on their side of the equation? Yes, which means we can go to the separate step. All you do is take the stuff from inside the absolute value bar, set it equal to positive version of 11, and set it equal to negative version of whatever that is. We've isolated, we've separated, we solve. What's nice about these is though they're different numbers, they're literally the same solve steps. Add 3, divide by 2. Add 3, divide by 2. Ta-da! Isolate, separate, solve. Now, so that you see what an isolating step actually looks like, part B is not isolated. You see how these absolute value bars are not the only thing on their side of the equation? We do some algebra to isolate them first. What do I do? Plus 15. So I have 5 times the absolute value of 1 minus 4x this time equal to 15. Still not isolated. Divided by 5. So then I have absolute value of 1 minus 4x equal to 3. Now that they being the absolute value bars are isolated, check. We separate. So we're going to have 1 minus 4x equal to positive 3 and 1 minus 4x equal to negative 3. Isolate, separate, solve. Subtract 1 from both sides. Divide by negative 4. Again, numbers are different, steps are the same. Subtract 1 from both sides. Divide by negative 4 on both sides. Okay, there's going to be two parts of today's lessons that are going to drive you kind of bananas, and it's the radicals with all of the foiling, and it's the questions that are going to be quadratic in form. So slow down on those. If you want to see one more example before I upload these to Google Classroom, I will work that last example out just so you have another example of the quadratic in form problem worked out.
So we don't have to worry about one like B on the homework?
I don't think so. But if it's there,
Its own power already.
it'll be actually, once you see the process in a couple examples, it's not as scary, but I felt everybody be scary, so we're going to pause for today. But what we are going to do for the last bit of class, let me turn this